Hello everyone, myself Rishiraj Das Ghosh from Coochbehar Government Engineering College. I am from Electronics and Communication Engineering Department. Today we are going deep into classification of signals, but not just the basic definitions. We are going to see both continuous time and discrete time versions for each type. So without wasting any more time, let's start. At the very beginning, we need to understand that what are signals. So in electronics, it's typically a time varying physical quantity like voltage, current or electromagnetic waves which are used to transmit data. In simple words, you can say that it is a function or pattern that conveys information. Now, signal can be classified into various different ways, but today we will be studying only the 5 ways, that is deterministic and non-deterministic signals, periodic and non-periodic signals, symmetric and anti-symmetric signals, energy signal and power signal, casual and non-casual signal. First, that is deterministic and non-deterministic signal. We need to understand that what are deterministic and what are non-deterministic. Deterministic. It is completely defined by a mathematical equation. That means which is predictable. Non-deterministic. These signals are random. That means which are unpredictable. Now let us understand this by a basic difference between continuous time signal for deterministic and for continuous time signal for deterministic and non-deterministic, and discrete time signal for deterministic and non-deterministic signal. Continuous time signal. Deterministic signal can be exactly described by a formula for all real values of t. As discussed earlier, that it is completely defined by a mathematical equation which states the same as before. We can explain it via example, that is a function x of t is equals to 5 sine 2 pi t, which is a continuous deterministic time signal which has a defined mathematical equation and can be exactly described by all values of small t. Now deterministic signal has exact value for each discrete index. This is the case for discrete time signal. In discrete time signals, the values of n must always be integer. No fraction or decimal values will come for the values of n. Non-deterministic signal is unpredictable. As said earlier, that the signals are random. Only statistical behavior is known. For example, random noise voltage over time. And non-deterministic signal for discrete time signal. In non-deterministic signal, values vary randomly with small n. That is unpredictable. For example, random sequence from a noisy sensor. Second, periodic and non-periodic signals for continuous time and for discrete time. For continuous time first, periodic continuous time signal. Let us understand this by taking an example so that we can understand the theorem and the overall definition of periodic continuous signal easily. Let us take a function x of t which is equals to x of small t plus capital T, where t is greater than 0. Now this t is actually the time period. So it states that any function x of t can be written as x of small t plus capital T. Let us easily understand this by taking an example. For example, x of small t is equals to 3 cos 5t plus pi by 6. Now, for calculating the period or fundamental period, anything, we first need to understand for periodic and non-periodic signals whether the function given is periodic or non-periodic. As the question suggests that it contains a sinusoidal function, then the function must always be periodic. So without wasting further any more time, let us dive into the formula. It states that any function can be written as x of small t plus capital T. So just write this function in the form of small t plus capital T. Then we will take the capital T part, that must be equal to 2 pi k, where we need to segregate the value of t, which will be our period. Now for calculating the fundamental period, we just need to put 1 in place of k, so that we can get 2 pi by 5. That is our fundamental period. And this value is obviously will be a fractional value or decimal value, and in continuous signal all these values are accepted. But for discrete time signal, there must contain only integer value. For periodic discrete time signal, x of n is equals to x of small n plus capital N for some positive integer n. Same thing, but the main difference is that this n value will be always a integer, positive integer, not unlike this a fraction or decimal. So x of n equals to cos of 0.01 pi n, where this pi 0.01 pi n can be segregated by capital N plus small n plus capital N. Then we need to find the value of small n while equal to 2 pi k, which comes 200k. Now for calculating the fundamental period, we just need to put 1 in place of k, that is 200. Non-periodic continuous time signal. No repetition for any values of t, that is time period. For example, e to the power minus 2 u of t. Non-periodic discrete time signal, sequence never repeats. For example, x of n equals to n dot u of n. Now the third, symmetric and antisymmetric. In this signal, we can give simple names to the huge names symmetric and antisymmetric. The symmetric can be said as even and the antisymmetric can be said as odd signal. Continuous time signal and discrete time signal, for both of the signals, symmetric and antisymmetric. Now symmetric, which is even, here a function x of minus t will always be equals to x of t. Antisymmetric, which is odd, a function x of minus t will always be equal to minus of x of t. Now for discrete time signal, symmetric, that is even, x of minus n will be equals to x of n, and for antisymmetric, which is odd, x of minus n will be equals to minus of xn. Let us understand thoroughly by this taking an example. Suppose we have a waveform. We need to check whether the signal is odd or even, that is antisymmetric or symmetric. If the waveform having both sides are the mirror image, then it is an even, but if it is not, then it is odd. So as you can see that this is an odd signal, this is an even signal, this is an even signal, and this is an odd signal, as because there is in some waveform there is mirror image and in some waveform there are no mirror images. And we need to remember few key points for calculating the symmetric and antisymmetric signal. Those are, for even signal, odd part is 0. For odd signal, even part is 0. Product of two odd signal is even. Product of two even signal is even. Product of two even and odd signal is odd. Now, fourth part, that is energy signal and power signal. Continuous time signal and discrete time signal for energy signal and power signal. So, energy continuous time signal, where the energy is finite and the average power is 0. That means it belongs that the energy belongs from which is greater than 0 but less than infinity, cause the energy is finite. The definition states that. An example is rectangular pulse. An energy discrete time signal, it is defined by a formula 0 less than summation of n tends to minus infinity to positive infinity modulus of x of n, which is lesser than infinity. An example is finite sequence. We will understand afterwards that what is this. Power continuous time signal. finite average power. मतलब means average power is finite and the energy is infinite, just the opposite of energy continuous time signal. Here the power is greater than 0 and less than infinity. Power discrete time signal. Here the average power is finite and the energy is infinite. Example, cos of pi n by 4, and here the example is sine of 2 pi by t. Now energy at continuous time signal is given by E equals to limit t tends to infinity integration minus t to positive t modulus of x of t whole square dt. And the average power for continuous time signal P equals to limit t tends to infinity 1 by 2 capital T minus t to positive t modulus of x of t whole square dt. Energy and average power at discrete is given by E is equals to n equals to minus infinity to positive infinity modulus of x of n whole square, and P n tends to infinity 1 by 2n plus 1 summation n equals to minus n to positive n x of n whole square. Now this energy is only given over here. That means energy discrete time signals, the range is from E is greater than 0 and less than infinity, and the example is finite sequence. Now last but not the least, that is casual and non-casual signals. Continuous time signal and discrete time signal for both casual and non-casual signals. Casual continuous time signals. Function x of t is equals to 0 for all t less than 0. Example, e to the power minus t u of t. Casual discrete time signal, x of n will be equals to 0 for all n less than 0. For example, e to the power n u of n. Non-casual signal exist for t less than 0, for example e to the power t. Non-casual discrete time signal exist for negative n values, for example x of n, which is equals to minus of n for all values of n. I hope it is all clear. That is all about the complete guide of the classification of signals for both continuous time and discrete time signals. Thank you.